Okay. All right, so welcome everybody. So I know a couple of people on the call here, and I'm privileged that I have a couple of other NLP experts to back me up and correct me when I make mistakes. So let's see. So today the topic is on NLP, and my experience in this meetup has been that it's a pretty diverse crowd of people, right? Whoops. Like lots of people from lots of different backgrounds. I know I've come and learned about things that I'd never even heard of before. So I wanted to talk about what I do at kind of a high level. So are you still looking at my Google Slides? Okay, cool. Okay, so I'll start by giving a little bit of an introduction about myself and what I do, and then go into NLP and a few specific applications. And then I'm going to use a hand-on demo using something called Google Colab. So I know that there are lots of different coding backgrounds here. This is going to be a Python demo, but it's going to be pretty high level and just kind of like click and run all in your browser so that even if you haven't used Python before, you can still kind of walk through the code with us. So I work at the Department of Veterans Affairs / the University of Utah Division of Epidemiology. And I work there as a data architect. Which is kind of an ambiguous term, but I'll go into a few of the specific projects that I do. But we at the Veterans Affairs get to do a lot of really cool work with clinical data and with AI or using that data. I also work as an adjunct professor at Utah Valley University. I teach an undergraduate course called Health Informatics Fundamentals. And in that course, we talk about how to use clinical information, where the information comes from, what kinds of interesting things we can do with it, including some stuff on NLP and machine learning. So a few of the projects that I do to give you a sense of what the kind of work I'm involved in is. So I'm focused on using clinical NLP and machine learning. So a few projects that this entails are biosurveillance, so doing monitoring for disease outbreaks and pandemics, which has been very involved lately. Using NLP to identify housing status. So COVID-19 isn't the only public health concern. Socioeconomic status, homelessness, is also a big issue. And natural language processing offers some key ways into getting insights on that kind of health problem. And another cool project that I got to do is work on machine learning to classify and forecast infectious diseases using that clinical data. So I don't know how much exposure a lot of you have had to NLP, but I'll give a quick overview here of what this is. So at a high level, NLP is one subtask of artificial intelligence. It deals very specifically with extracting information from human readable text, which sounds, when I try to explain what I do and what NLP is to like my family, to my in-laws, it's very frustrating because that just sounds very simple, right? It sounds very easy. But as we'll see, it's really quite a tricky problem, and it takes a lot of effort to get something which can be intelligible to a computer out of this text. And NLP is really useful because there's a lot of unstructured text data out there in the world. Across different domains, a huge section of the data that we have is unstructured. But even though we have all that data, you have to do a lot of work around it to make it computationally usable and useful. Feel free to stop me with any questions or comments that people have. So a few specific applications of natural language processing. So one is called named entity recognition. And this is where we take a snippet of text and we look through that text for specific entities which can be found there. So here's an example where you can see that a model has extracted mentions of certain concepts like people, so people's names, organizations like Google or dates. And so by using this, this is kind of one of the prime examples of NLP, where you can use it to extract the specific useful information which you can then use in whatever application you have. Another might be document classification. And you can imagine this might be useful is if you look at like Google News, for example. Google News does a really good job of taking this massive amount of text information that it brings in, and then being able to classify as being related to sports or entertainment or technology. And that's how we get that kind of curated news content that we're all used to. Machine translation. So I remember when I was in college and I was studying German, and the professor said to us, never try to just type your homework into Google Translate and put it into an answer. We'll always know because Google Translate is terrible. But that's really changed a lot in the last few years because the methodologies behind those translation engines have gotten a lot more sophisticated. And it's all due to these advances in natural language processing that get to these really good translation models that produce really high quality translations from one language to another. So for those different types of NLP problems, where are some applications in the real world? How can these be applied to different domains? So what's really cool about NLP is that any domain that involves text, you can use it. And what domain doesn't involve text in some way? So one is news, like I already said, categorizing different events, extracting events as they happen. One is law. So I've heard of like law agencies that when they're reviewing a case, there's just such a wealth of information of legal journals and documents related to the case that it's really not feasible to look through them one by one. So NLP can go and look across all of that information and quickly extract what's needed. Another is e-commerce. So if you have two different products with text descriptions of them, you can measure how similar those two products are based on the similarity of their descriptions. And text similarity is a really common task in NLP. And one more that I thought of is customer service. When you go to a website and you talk to the assistant, it might just be some NLP-powered dialogue agent behind it, coming up with the answers to your questions until it gets to a point where it can't answer and sends you to an actual person. So like I said, I work with NLP in medicine, so clinical NLP. So what we work with as myself and also Patrick, who's on the call, and Kelly, we work with data which is stored in electronic health records. So you might be used when you go to see the doctor. It's kind of a joke that they'll spend 1 minute looking at you and 10 minutes looking at their computer. Because medicine is a really information-rich industry. Every time you go to see a doctor, a bunch of information and data is generated, and it's stored into this EHR. And this includes a lot of text data. So some examples of what we can do using NLP with this data is you can find important medical events in the patient history based on the data that was put into their EHR. I'd referenced earlier that I do some research on homelessness. So these notes might talk about how a person is living, if they're having any economic problems. And those are really detailed information that might be written in notes, but not found in other places. And the last one is biosurveillance. So with this, I have kind of a specific example of how NLP can be used in this case. So here's a link to the VA's National COVID-19 dashboard. So if you go to the link, it's very interactive, and there's really granular data here. They break it down by how many active cases there are, how many are recovering, how many deaths have happened, and you can break it down geographically across the country. Now, if you go to the page, there's a little frequently asked questions at the top where it gives some definitions on where does this data come from? How did they get it? So it all comes from the electronic health record, and some of it comes from using natural language processing, and I highlighted this here. So like I said, those clinician notes are really useful. And here is an example of someone going through and mining this data using NLP to come up with something which is actionable. And given that this is a pandemic, something that's really relevant and important to pull out. So are there any questions on NLP at a high level and how it's used in these different domains? I did see one question about recordings, and I think that Brian is recording this and we'll post it on the Slack channel, or the Meetup channel.
Correct.
Cool. Okay, if there are no more questions, I'll go into a little more detail about how NLP actually works. So at a high level, there are two different types of NLP models. So the first is rule-based. And what a rule-based model is human experts take the domain knowledge, take the concepts that they know they're interested in, the kinds of logic that surround those concepts, and they encode them in a computational way. And these experts then engineer these handcrafted rules, which are basically trying to replicate human knowledge and human decision-making. So this diagram shows kind of a really simple representation of this. We have some knowledge base, which might consist of rules or facts, and these might just be as simple as phrases which mean a certain concept, or it can be something more sophisticated. When you've developed this knowledge base, you can apply it to your set of documents, the free text notes that you're working with, and then that's going to pull out these structured predictions, which, because they're structured and they're no longer just natural language, can be used for some computational purpose. So that's rule-based. And some people tend to call that the old-fashioned way. And the second type is statistical NLP. And if you hear about most NLP research today coming from big people like Google or IBM, they're probably talking about some kind of statistical model. So statistical NLP models use machine learning under the hood. So instead of creating those rules, those handcrafted expert rules, they take a bunch of data and they label that data to show the examples that they're interested in. And then they pass that text into a machine learning model, which is trained to extract those concepts. And I'm not going to go into too much detail of how machine learning works, but it's this general process of take your data, give it to a model, train, and then eventually you can predict with that model. So with NLP, something that is important to emphasize if you're talking to customers or maybe stakeholders in your model is that NLP is never perfect. And the AI that we develop is always going to make mistakes. And part of this is just because text is really, really complicated. There's a lot of ambiguity in text. So words which might mean different things in different contexts. Or there can just be really complex ways of saying things, lots of different patterns that you or your model didn't think of. So whenever you're working with an NLP model, you always measure how well it does based on these certain metrics, like precision and recall, which tell you how many false negatives you have. So for example, if there's a case of COVID-19 out there and you don't find it, that would be a false negative because your model missed it. Versus false positives. How many times did it predict that some concept was there, but it actually wasn't? Okay, so any final questions before we jump over to the hands-on part?
I'm curious about why maintaining context is so hard. It seems like one of the big problems with language processing is that the model loses track of what's happening. Like, Siri forgets after 2 sentences what you were having her do, or other models like that. What are some ways that that's dealt with, or the improvements that have happened in the last few years?
Right, that's a really good point. So if you're looking at text data, which is either like spoken, like you said with Siri, or a document, there's a lot of information there. And if you try to just process the entire document or the entire conversation all at once, that's just too much information to keep track of. Just computationally, it's just like this explosive space. So in NLP, you make certain assumptions. And some of those assumptions might be that you just look at one sentence at a time. Or you just look at, if you're looking at a word, you just consider a few words before it. And that assumption then makes it so that it's computational feasible because you're ignoring a lot of the noise out there. But like you said, it leads to lots of mistakes and leads to like a really limited understanding of what's actually being discussed. So I know of a few methods that I've heard of where, for example, like if you encounter a term in one place in the text, you figure out what that term means, and then anytime after that, you try to go back to that. Kelly's giving in the chat some examples of pronouns. So let's say you ask Siri, I would like to go to McDonald's. How do I get there? Then you want to know that there responds to McDonald's. And that's something called co-reference resolution. And that's kind of a simple example. What about if you have an entire conversation and different people talking about different things, etc.? So I guess the kind of short answer is that's still a huge problem that the community hasn't really solved yet. But Patrick or Kelly, do either of you want to add on to that of kind of what kinds of approaches have been made to improve that? And maybe they're stumped, like I am. Kelly doesn't have a mic. But yeah, it's a really hard problem, and that's just kind of a perfect example, Brian, of the limitations of NLP.
Cool, thanks.
Cool. Okay. So if there aren't any more questions, let's jump onto the hands-on part. So I created this demo, and this is an adaptation from a module in my course, but a little simplified. So even if you haven't used Python, that shouldn't be a problem. And I'm hosting everything on Google Colab. And you can also use it locally if you'd like, but I recommend, at least for now, just doing it in your browser. So I'm going to post this into the chat, this link here. So even if you've never used Python before, open this up, and I encourage you to follow along with it. So I'll take a minute first just to kind of orient. You know what, actually, I want to do this. I'm going to do this in incognito so that we see the same thing. So if you've ever used Jupyter Notebooks, Jupyter Notebooks are a sort of like Python IDE where you have these interactive code cells where you can edit code and run it and see the output, mixed in with these human readable markdown, where you can write text for your viewers to read or notes about your code. So it's really popular in data science and in the Python community in general to use this format. And Google Colab is this online free resource provided by Google where you can host your own notebooks or run other people's notebooks. You can even use like GPUs to get kind of more powerful performance if you're using like deep models. So this is a notebook that I made, and if you want to do it interactively, you can open it up in the playground mode or save a copy and then use it just like you would any other Jupyter notebook. So if you've ever used one before, you can either run a code cell. This is a code cell here by hitting play. Oh no. Okay, you have to be signed in with Google, apparently. That's a limitation. So I'll just go back here. So you can either hit play, and then this is on the back end running this Python code, or you can do Shift Enter, and that's just a shortcut. Okay, so in these notebooks, I'm going to start by giving an introduction to a really popular Python tool for NLP. And then I'm going to show how to use this package, this library, for a much more specific application of clinical NLP. So spaCy is a really popular Python library. It's a package which is specifically built for natural language processing, and it offers a lot of out-of-the-box tools for processing and analyzing text. But one of the really great things about it is it also allows you to really extend and contribute to it so that you can do a lot of really custom and sophisticated things with NLP. So most of spaCy consists of statistical NLP models. So like we talked about, those are where you train a model based on data to predict certain concepts or do certain tasks. But even though those are the statistical models, we will see some examples of where those kinds of machine learning models have limitations. And spaCy also gives you ways to use rule-based methods to extend that. So one thing that spaCy provides is a few pre-trained models. So you can just read in a model and immediately start doing NLP. This notebook is going to be a really high-level introduction, but if you want more information, they have really, really good documentation. And they've also got a great course online, which is free if you really want to dig deeper into how to use spaCy. So let's start by just seeing how do you get started with spaCy. So the general workflow of spaCy is you take a pre-trained NLP model and you read it in, and then you process a string of text with that model. Once you've processed that, you have access to a lot of different linguistic information and analysis based on that document. So the way that we read it in is we've already imported spaCy into our workspace. And then we do this NLP equals spaCy.load. Then we take a text, and here's a little snippet from a news article about Taco Bell, and you process it. So you say NLP text doc equals. So now this doc, this is our processed text, which contains a lot of the NLP-derived information that we wouldn't have access to without having first run it through an NLP model. And here's one example of what that is, and we'll go through in more detail of what this is later. So let's dive a little deeper into how spaCy is structured and how we work with it. So that NLP model is our trained statistical model, and it's the starting point for all of the processing that we're going to do in spaCy. So there are lots of different models, and I'm going to open up the spaCy documentation here to show some examples. So they've got support for a number of different languages. We're doing English, but Spanish and German, and there's lots more in the community that you can get. And once you do that, you can go through and start processing your text in these different languages. This is kind of the default English one that we're using here. So once you take your text, that generates these new data types. And we're going to go through just a few of these that represent our processed text at a few different levels. Like we said earlier, the doc represents a single document of text, which has been processed. So if we take this one sentence and we process it by saying doc equals NLP text, we now have this object, which is a doc, and in the surface just looks the same as our text. But we're going to see that there's now a lot more information within it. A token is a single word or symbol within a doc. So if you take a sentence and you split it up into all the individual words, in linguistics, those are all called tokens. So if we take this doc and we look at the first token, we see that it's taco. If you go up here, that's the first word. And then you can loop through the doc and see all the different tokens which are included here. So one thing to point out here is that it's not a straightforward thing of how to actually do this splitting up, or it's called tokenization. So you could just split it up based on white space. So say, words are separated by spaces. So just split it up that way. But spaCy does it a little more sophisticated. It splits up the apostrophe S, so you have that possessive part. A comma is considered its own word, this dash, etc. So if a token is a single word, a span is going to be a slice of the document, or a few tokens consecutively. So if we take the docs and index it 1 through 4, and if you're used to Python, this is the same way that you would index like a list in Python. It's going to be those words, words 2 and 3 and 4. And this is going to be of the type span. So that's all interesting, and that's just kind of the basic API of spaCy. Now let's look at what information is actually included here. So now that you've processed this, you've got these linguistic attributes that you have access to. So one of the first ones is part of speech tagging. And this is one of the really basic and fundamental tasks in NLP. So if you think back to like 3rd grade or 4th grade, you learned all about nouns and verbs and adjectives. So POS tagging teaches a computer to recognize those different types of words. So if we loop through our doc again, we'll look for each token. We'll compare what the text of the token is, the actual word, with the part of speech tag. So it calls taco and bell a proper noun. Let's see, adjective for latest, marketing, noun. And if you don't know what these mean, you can call spaCy.explain to remind yourself from 3rd grade of what these mean. This might not be useful on its own, but it is going to be useful later when we want to do some more sophisticated analysis that we're going to have information about what types of words we're dealing with in our text. The next NLP task is called lemmatization. And that's where you take a word and you reduce it down to its root form. This is useful because when you pass in a document to an NLP model, there's a lot of variation in there. There's a lot of different forms of it, and sometimes you just want to condense it down to be a little simpler and a little more straightforward. So for example, if we take this, we can reduce latest down to its lemma of late. I'm trying to see opened goes down to open. So this helps simplify the text and means that there's a little less information that your model has to deal with. So these are what we might call upstream tasks. It's not really that useful to just take a sentence and figure out the part of speech for all of them. It's interesting if you're a linguist like Patrick, but to your average person, it's probably not going to be that useful. But you build from these building blocks down to more useful tasks like NER. So we already talked a little bit about named entity recognition, which is where you take text and you extract specific entities from it. And often this might mean things like people, people's names, or geopolitical entities or organizations. So let's take this news article from The Guardian, process it with our NLP model, and then we can use this function provided by Spacey for visualization to see what it extracts using NER. So like the example we saw earlier, we can see some geopolitical entities like Germany and the UK, London. You can see time intervals, organizations, etc. So one thing to consider while you're looking at this is how does it figure these out? What kinds of patterns does it extract? Because this is all statistical, meaning that it wasn't trained based on rules that you wrote, but by examples that it was given before. Okay, now to go back to that Taco Bell example, because I think this is a really good example. If we take this news article, here's what it pulls out. So it recognizes Taco Bell as being an organization, recognizes these time periods. So for context, this is a news story about when Taco Bell opened up a hotel. And this is the bit that I really like. It says the resort has been called The Bell, a Taco Bell hotel and resort. And Spacey predicts that that is a work of art. So while you are entitled to the opinion that a hotel created by Taco Bell is a work of art, I might say so, I would call that a questionable prediction. So does anyone on the call, either you could type in the chat or speak out loud, why do you think it called this a work of art? Any theories or hypotheses?
Sounds like an intellectual property term.
What does?
Work of art in that case, and maybe I'm just honing in on, the bell as a trademark phrase of Taco Bell.
Yeah, that makes sense. Yeah, so like if you think of actual works of art, you might have like the Mona Lisa or the David. So having this phrase at the top might be kind of a clue to the model that it's talking about an art piece here. So let's see if we take one fun thing to do with NLP models is to mess around with the text and see how it changes based on what you do. And that's fun because you can kind of trick it into thinking certain things, but it also then explains to you what your model is actually doing. Okay, so it still does that. What if I take the quotes out? Okay, so without the quotes, now it thinks that it's an organization. What makes it an organization? Maybe it's that everything is capitalized. So let's see, if I take these and lowercase it, now it reduces down to a smaller phrase. So doing this, you kind of start to get a sense of how the model is making its decisions and what kinds of linguistic patterns it's picking up on. But this is one disadvantage of those statistical models that we talked about. So even though deep learning and machine learning is the big topic right now, one con of it is that you can't really fully understand what the model's doing. And it might pick up on weird things like calling Taco Bell a work of art, and you can't necessarily know why that's happening. So once we've processed this doc, in addition to highlighting this, we can go through and look at all the entities and the labels that we had in the doc.ents attribute. And we'll see some more examples of this later. So how does spaCy get all this information? So far we've seen that it had part of speech tags, lemmas, the root forms for words. How does it do all of this? So under the hood, this NLP object consists of a pipeline. And in NLP, a pipeline is consecutive steps which we take to process the text. So if you look at this here, you can look at nlp.pipelines, and that tells you step by step what is happening to the text. So first it goes through the tagger, and the tagger gives it those part of speech tags that we saw. Next, it's passed into a parser, and that gives a dependency parse, which I didn't show an example of here, but basically that shows the model how the sentence is structured. And then it goes into the NER and pulls out the entities that we see here. So the big advantage of doing this is that it's a modular format, meaning that you're not just throwing the text out and doing a bunch of stuff to it. You're doing it in little controlled steps. And as we'll see later, spaCy lets you add in additional components, including ones that you created by yourself. So the examples that we looked at here, these are all general purpose. They're general domain. We've used English news articles. Wikipedia is another example of these just really high-level, generalized languages. But if you're going to work in a specific domain, like language or law, the language is going to be very different from that of others. So you need to have different models and different processing steps. So in this next notebook, I'm going to show an example of how we can extend spaCy to specifically look at clinical text and do some of the tasks that we're interested in, or I'm interested in, at least. All right, so this is a new notebook. So we're going to run this and import our libraries again. So like I said earlier, in healthcare, there's a lot of information generated and stored in free text. And all that text is stored in the EHR. And by default, it just kind of sits there. Doctors might go through it when they're reviewing a case or before they see you so that they get an idea of your history. But from a computational perspective, you need to do some extra work to get relevant information out of it. So that's what clinical NLP developers are focused on. So in this notebook, we're going to show how you can use a model which was trained specifically on clinical text, can pull out relevant clinical information, and then some additional processing steps that we can take to make sure that that information is relevant and accurate. So as we said earlier, statistical NLP, you have an annotated corpus and train it to recognize certain concepts. So the model that we had before looked at people, geopolitical entities, works of art. Those aren't relevant to us. So we're instead going to look at these clinical concepts, problems, so patient diagnoses or signs and symptoms, tests that they've had or procedures, and then treatments, medications or therapies for those problems that they have. I'm not going to go through in detail of how I trained this, but this came from an open shared task from I2B2. So this is an organization which shares NLP competitions for clinical NLP. And once I trained it, I put it up on GitHub, and now we can just read it in and use it as a pre-trained model. So the way that you install it is I'm going to point it to my GitHub repo. And it's going to take just a second to install this. And again, if you're doing this on Google Colab, it's all doing this on the cloud, so you don't have to worry about your own environment. And then we're going to load it in just like we normally would with the spaCy model. Now, this is kind of annoying. This is something with Google Colab that once you install it, you have to restart your kernel. So the way that I'm going to do this is hit runtime, restart runtime. So this is going to reset the kernel that I'm using. Run before, so I'll run everything up until here. And then when it's ready, we can read it in. And now we have our NLP model. So let's look at what is underneath the hood in this model. Let's look at the pipeline. So we've got a tagger, a parser, and an NER. So this is exactly the same as the pipeline that we had over here, the default Spacey one. But the difference here is going to be the labels that the NER model predicts. So here are those three concepts that we are interested in, specifically clinical concepts. So now that we have this model, let's process some clinical text. So if we take our text and run it through our NLP model, we get a doc. Let's look at the entities that were extracted. Right now there are two, ABX and his infection. And we can see that this is called a treatment. So ABX is an abbreviation for antibiotics. And it recognizes his infection as a problem. So that's good. So in this sentence, at least, it recognized things pretty accurately. Here are a few more sentences. This is the kind of language that you'll see in an EHR, talking about their problems, their family members' problems. We're going to process this with our NLP and see what it comes up with. So let's see. So glancing at it, so I'm going to skim through and try to see if there are any mistakes or anything that I disagree with. And shout out if you see any. So it mostly looks pretty good, but there are a few things that I would say are maybe a little questionable. So here it recognizes CKD stage 3. That's chronic kidney disease. And these diseases are classified into these different stages based on severity. So it recognizes that as being one phrase. But here it only looks at CKD stage and not as 4 as a stage. So that's kind of problematic because that means that your model is missing out on important information. Here it recognizes this as a drug name, as a treatment. And here it has her atrial fibrillation and her AF. So in clinical text, AF might stand for atrial fibrillation. It can stand for a lot of other things. One problem here is that the NLP might recognize both of these as a problem, but it's probably not going to recognize these two phrases as meaning the same thing. So that's kind of a limitation of this model that we have so far. Okay. So our model is doing a pretty good job. It's getting relevant information. Most of these, I would say, are pretty valid predictions. But now let's think about how, all of a sudden in January of this year, we had this huge medical problem come up of COVID. And this model was trained on data based from 2012. So no one had even thought of the word COVID yet. And let's say that we want to start doing some biosurveillance where we start detecting any mentions of COVID-19 in text. Let's see how our model does with this. So we'll process this text. He presents to the ER for possible COVID-19. Let's see if it extracted any entities. It didn't. It spits out this empty list. And then if we try to display this as seeing an entity, it tells us nothing's highlighted. The model hasn't found anything. And to Kelly's question, which is a good one, does anyone know the meaning of COVID-19? Or of COVID? What is it, Kelly? Could you? Yeah, Kelly and I have been working on this for weeks, and I'm trying to think if, so it's coronavirus. I used to know, I think. Oh, disease. That's what it is, yeah. Yeah, so that's kind of an example of how in medicine we deal with these phrases that we might not even know where they come from, but they might be composite of lots of other different words, and you can have lots of different forms or spellings. So like Kelly gave some good examples of you have coronavirus disease, COVID, coronavirus from 2019, novel coronavirus. There's 100, infinite different ways to say this. And right now, our model is not recognizing any of them. So what are we going to do about this? This is obviously not good, because if all that we have to work with is this model trained on our old data, we're not going to be able to adapt to this new and very urgent medical situation. So here is where we see a limitation of statistical NLP and the advantages of rule-based systems. So I'd said in my presentation that rule-based systems are sometimes thought of as being old-fashioned because they've existed longer. But in lots of ways, they can do things that statistical models can't. So because our machine learning model didn't recognize this phrase, but we did recognize it. So we're going to write some rules to add this to our model. So like I said, spaCy has a lot of different ways that you can use rule-based systems. And if you go to this documentation here, you can see much more detailed examples than what I'm going to go through in this notebook. But what spaCy provides are using those attributes that we had, like parts of speech and lemmas, you can pull out a lot of really detailed information using rules. So one way that you can do this is a class in spaCy called Entity Ruler. And what the Entity Ruler is it's basically the rule-based complement to the NER model that we saw before. So what we're going to do is we're going to import this class from spaCy, instantiate something called a ruler, and then we're going to write a really simple rule. So in a really simple form, here's what a pattern looks like. So we have the Python dictionary with these curly brackets, and we assign a label, which is problem. And the simplest pattern we can do is just the phrase that we want to pull out. So we're going to add this pattern to our entity ruler. And then this one line of code is one of the really, really powerful things about spaCy, that you can take this new component and just add it to your NLP like this. So we say nlp.addPipe, and then if we look at the pipe names again, you can see all the components that we had before plus this new one. So now when we process our text with our model, we can see that it does recognize COVID-19 as an entity, as a problem. So this is just one example of a rule, but we could go through and find all of these more complex examples, like what Kelly and John were saying in the chat. And we can use really sophisticated ways to pull out that information, which a statistical model wasn't able to do. Okay. Any questions on spaCy right now before I go to this last section of the notebook? Okay. So last thing I'm going to talk about is something that's really specific to clinical NLP. And this is contextual analysis. So there were some examples earlier of sentences like this one. There is no evidence of pneumonia. If we run this through our model recognizes pneumonia is a problem. Great. Our model is done. It recognized its problem. It did what it's supposed to do. But if we take a step back and think about what is our use case, we're trying to find information maybe about a patient, find out what problems the patient has during this hospital visit. And even though pneumonia is here and our model recognizes it, the patient doesn't actually have it. So it's not enough to just recognize this phrase. You need to do some more analysis for it to be actually usable in the real world. So one way that you can do this is by something called context. And there's a link here to the original paper, and this algorithm is kind of near and dear to my heart because it's kind of a family history in this one. So this is a really common algorithm in clinical NLP. And here are a few different systems which use this. I'm going to give just a really high-level summary of how this algorithm works. So if you have a phrase like pneumonia, which is the target, the main concept that we're trying to pull out, you then take that target and you look in the context around it, so the neighboring text, like the sentence, and you look for linguistic clues telling you, does the patient actually have this? So in this, we have a target of pneumonia, and then we can find this modifier of no evidence of. And this phrase is telling us that this problem here is not actually experienced. The patient doesn't actually have it. So context basically builds a graph between these different concepts to tell us which conditions the patient actually does or doesn't have. So the way that we can use this algorithm in spaCy is something called spaCy. And this is a package which was written by a few people on this call, including myself. So this is part of a project called spaCy. And what we're trying to do in spaCy is build these different spaCy components for really common NLP tasks. And then you have this kind of spaCy-driven way of doing clinical NLP. So we're going to install this here from pip. Pip is the Python package manager for those who haven't used it before. And then we're going to import it, and we're going to instantiate our context object. And then we're going to add it to our pipeline, and we'll look at our pipe again. We can see that we have all those previous components plus a context component. So let's look at what this algorithm looks like. So now when we process the sentence, we recognize the phrase pneumonia as being a problem, but we also see that there's this other phrase, no evidence of, which is telling us that pneumonia is negated. And here are two visualizers that we can use with this package. The first one highlights it, and the second one shows the relationship between these different phrases. So this phrase of no evidence of is negating pneumonia. And then when we look at the span of text, which was pulled out by Spacey, we can also see that it's negated. So now we have a way of knowing that this concept that we found in this text is not actually present in the real world for the patient. So negation is just one example of this, because clinical text is full of examples where a condition is mentioned, but the patient doesn't actually have it. So some other cases of this might be someone else other than the patient had it. So for example, you go into the doctor and they ask you about your family history, and you fill out that big form. And so the doctor might write in their note, her mother had breast cancer. She doesn't have it, her mother had it. Temporality. So past medical history, meaning that the patient used to have these conditions, like atrial fibrillation, CHF, and CKD. And some of these might have just been one-time things. So saying that it happened in the past means that they may not have it anymore. And also certainty. So when you go to the doctor is trying to figure out, what do you need? What problems do you have? And they go through a process of diagnosing you. So when you first come to the ER with a cough and a fever, they're not just going to assume you have COVID, but they might say that you have possible COVID-19 and that needs to be evaluated. So if we take these texts and we process them with our NLP, we can go through some examples and see what our model pulls out. So her mother had breast cancer. We can recognize mother as a family modifier and breast cancer as the problem that we found. And here it shows you that it was the mother who had the breast cancer. Let's see. Past medical history for AFib, CHF, and CKD, all of this is historical, not current. Possible COVID-19, so there's that uncertainty of the possible existence. Negative for influenza, it's negated. And it's not just problems that this might be, it might also be medications. So he's not currently taking any beta blockers. That treatment is being negated in the text. So that's the end of the summary that I have here as an introduction to NLP and to clinical NLP. But I wanted to give some resources if you're interested in learning more about natural language processing, because it's a really cool and interesting field. And like I said, it's relevant to any domain pretty much. Anything that uses text can use NLP. So some of the resources I wanted to give are this Advanced NLP with Spacey is a free, relatively short course provided by Spacey, showing how to use this package in a lot more detail. It's a really good course, and they have it in a few different languages, which is really cool. Here's kind of the classic textbook that you might use if you are studying NLP in a university. Fast AI is a popular open source data science education program, and they have a natural language processing program. I'd actually like to try this course out myself. And there are a few more resources here as well. So are there any questions that I or anyone on the call can answer about NLP or how we use it? If not, I'll assume I explained everything perfectly, and you all are masters of NLP now. So Brian, that's all that I have for the presentation.
Perfect. That was great. I learned a bunch from that. Any other questions from anybody? We'll give it for some Q&A and then kill the recording.
I had a couple questions.
Go ahead.
So with Spacey, have you ever used anything like BERT or Flare or any of those?
Right. So I haven't myself as much. Maybe Patrick or Kelly have, though. But they do have support for that. So there's like pre-trained BERT models that you can read into Spacey and just use off the front. So I haven't myself, but it's there and it's very usable.
Okay. Okay.
That's a great question, though.
Thanks.
Let's see. Kelly had a question of what is the hardest challenge you've had working in COVID surveillance? Yeah, so Kelly and I have been working on this surveillance system of extracting mentions of COVID from text, and it's been a really hard problem. So I think the big problem there has been this extremely high volume of data. So we've been doing this since January, and there's just a lot of notes about NLP. When you go to see the doctor, they're pretty much guaranteed to mention COVID. And so trying to get a grasp of that large volume while also dealing with how the concept is changing. So Kelly and I started looking at COVID in January, and the word COVID didn't exist. We were calling it the new coronavirus. Back then, doctors were interested in, like, if you just come back from China and you had a cough, that was really problematic. But fast forward 2 months, all of a sudden, everybody has COVID. And anytime you come into the hospital, they might suspect it. That really changes your understanding of what the disease is and what you're looking for in doctor's notes. Yeah, so I think kind of those two things have been the big challenge. But there have been lots of challenges. It's been a really fun but challenging project. How many synonyms of COVID? Let's see, I'll start by just naming a few. So there's COVID, COVID-19, SARS-CoV-2, the disease caused by SARS-CoV-2, the new coronavirus, the Chinese coronavirus, nCoV. So I guess, I don't know, at least, like, I'd say at least like 30 kind of core different forms, and then many, many different variations on each of them, which you can kind of get by using some of those rules from Spacey to not just look for specific phrases, but do something a little trickier. So Kelly asked, why do you think Python has been used so much for NLP? I think partly because Python has a really great kind of open source community. And Spacey is just a really prime example of this, where it's this open source software that lots of people contribute to, and people build extensions off of and additional functionality. And Python then just kind of lets you relatively painlessly utilize that work done by other people and bring it into one. So for something as challenging and as fast-paced as NLP, that open-sourced format is really an advantage. Yeah, you should try it, Kelly. I think you'd be into it. Maybe, you might have a steep learning curve at first, but just kidding. Kelly's a Python master. I learned most of my Python from him. Cool. Well, Brian, I will send out these notebooks, or I've given them to you already. I'll also put the slides up in that repository so that people can have access to them after if they'd like.
Excellent. Thank you very much. That was well done.
Yeah, thank you everybody for joining, and feel free to ping me if you have any questions after.
And if anybody else wants to speak on something, ping me and let me know. We're open for all kinds of stuff.
Cool. All right. Thanks, everyone.